Good afternoon, everybody, and welcome to a discussion about an interesting topic these days, namely applying core DevOps principles to data science projects, to projects that incur the use in any form or shape of machine learning. Specifically, when I say they incur the use of machine learning, I'm saying training models, evaluating machine learning models, and obviously publishing machine learning models. And this talk is focusing on the tools and platforms that we have available in the Microsoft world. So it makes sense to start our discussion with an overview of the most important platforms and services that are currently involved in data science projects in Microsoft Azure. Obviously, there are several services, there are several platforms. What I'm going to focus on is two of them, which are, in my opinion, the most important ones: Azure Machine Learning Service and Azure Databricks. How many of you have already used in any kind of form Azure Machine Learning Service? Great, nobody. How many of you have used Azure Databricks? Great, nobody. So this is going to be an interesting discussion, right? Because I assume that you are here to understand how these platforms and services can help you in your potential future projects. Now, Azure Machine Learning Service is Microsoft's central service for managing machine learning projects. And it provides you with several types of features that are super important when you think about running such a project. These resources provided start from compute resources, various types of compute resources that you can use to train your models. It provides you with tracking and traceability of trained models, so you can basically register your trained machine learning models. They will be versioned, and then they will be tracked through their entire life cycle, from training up to publishing into production, and later on when they are used for either real-time scoring or batch scoring. It also provides you with support for pipelines. Pipelines are a feature that enable you to define machine learning specific flows, machine learning specific workflows that are part of your processes. For example, I'm going to show you today a simple pipeline that contains two steps. One step will train a machine learning model. The second step will check whether the performance of that specific machine learning model is better than of the ones that were already trained. Because obviously, when you think about automating your entire process end-to-end, the last thing you want to happen is automatically train a machine learning model, get a model that is worse than the one that you already have in production, and then have that model pushed in production, replace the better one. So this is quite important. As you will see today, that the complexity involved in implementing an end-to-end process with DevOps approaches are a little bit higher and different with machine learning projects than they are with regular software development projects. And then you also have some other types of features, like, for example, automatic deployment of services via Azure Machine Learning Service. We will see in a moment that you have two major options. You can either deploy as an Azure container instance, which is good for dev and test scenario, or you can deploy your trained models via Azure Machine Learning Service using an AKS cluster, an Azure Kubernetes Service cluster, which basically gives you a production-grade environment to run your trained model. Everything that is available in the Azure Machine Learning Service is exposed to the outer world via an SDK, a Python SDK, the Azure Machine Learning Service Python SDK, which basically enables you to automate every single aspect of Azure Machine Learning Service in a Python environment, any kind of Python environment. And when I say any kind of Python environment, you can think about, for example, a simple command prompt that has access to a Python environment. Or you can think about, for example, a development environment like Visual Studio Code. Or you can think about an environment like Azure Notebooks, which is Microsoft's free offering for a Jupyter Notebook environment. And there are several other environments, Python-compatible environments. Any Python-compatible environment can be used to automate these services. On the other side of the slide, you can see the other major service, which is Azure Databricks. Databricks is essentially an implementation of Spark. It is a Spark environment that provides advanced features and services for data handling. So basically, with Azure Databricks, you can implement even the most complex data preparation scenarios that you can think of, starting from static data to data that comes in through any kind of streaming channels and so forth. And the power of Spark resides in its capacity for handling multiple workloads in parallel. Azure Databricks clusters provide you almost unlimited computing power that you can use for those Spark jobs. And there is also a component in Spark called MLlib, Machine Learning Library, which enables you to train machine learning models even inside Spark, if you will. So you are not forced to do it necessarily in Azure Machine Learning. You can also do it in Spark. And for that matter, you can actually train your machine learning models wherever you want. Whatever is the environment of your choice, the principles and the things that we're going to cover today apply as well. So this is basically the 10,000 feet picture of the most important services in the Azure platform that are going to be involved in implementing an end-to-end DevOps-style pipeline for a machine learning project. And let me dive a little bit into the specifics of machine learning projects, because as I mentioned previously, these projects are different from what we know to be the classical software development project, simply because they have one additional type of workload which is very, very present in machine learning project, the experimentation. There are a lot of people in this world who actually do not understand the fact that machine learning is mostly about trial and error. Right? There is this aura for machine learning. People are thinking, oh, these guys are superheroes, these data scientists, and they take out of their pocket a magic solution and everything works perfectly. It's as far from the truth as possible. Machine learning is about a lot of trial and error, and in the science and research world, we have a fancy name for this. It's called experimentation. So what you need in order to have a proper DevOps approach for a machine learning project, you have to acknowledge that this actually happens in such projects. So experimentation is a super, super important part of it. There is another interesting thing that makes a big difference between a machine learning project and other types of projects, and that is, think about code versioning, right? Code versioning is kind of been there, done that for everybody. We all are familiar with source code repos, and virtually everybody in this world uses them today, right? That's easy. The problem with machine learning projects is that in addition to code versioning, you actually need to handle data versioning as well. Because the reason, at the end of the day, the reason why you want, or the reasons why you want a DevOps process, an end-to-end DevOps process, are actually two. So two are the main reasons. First is automation, obviously. You don't want to do things manually. But the second one is traceability. Think a little bit about the final form of a machine learning model. Let's think about it as being exposed as a web service. And that web service has a REST API, and you call that REST API with some inputs, and then you get some outputs which are the predictions. The core question that you need to answer is, how come that particular service provided that particular prediction for that particular set of inputs? And you need to be able to trace this back, all the way back to the source code that has been used to train the model, and the snapshots of the data that have been used to train and test the model. This is one core aspect of machine learning projects that makes them fundamentally different and more challenging than classical projects. That traceability part that needs to cover data as well. And then, of course, you have the development part where you will do the same things, developing, you will do training your models, you will test your models, and obviously what you want to do is have CI/CD. Now, the problem with CI/CD is that, before saying this sentence, let me put a question. How many data scientists are in the room besides me? Okay, good, then I can say it, right? Having CI/CD is kind of a killer thing in the worst way possible for data scientists, right? Data scientists are used to experiment. They need to run 500 versions of their Python code and train the models and see what happens and save them on 250 different places on their disks, and then search for the best version and then forget where the best version was, and then mix source code and then try again and then test again and then create a bigger VM because they don't have enough resources, and then losing their source code and then recreating it and so forth. Basically, this is a sort of description of a half an hour from a data scientist's life. So getting the rigor of, and just don't get me wrong, I am a data scientist, so I know what I'm speaking about. I've been there, I've done that. I've managed teams that have been there and have done that. So having CI/CD for machine learning projects is not only a technical challenge, but it is also I call it a soft skills challenge. Because teaching and helping people understand this is good for them, especially for data scientists, is a very difficult task. And finally, obviously, we're talking about ops, so we need to have the operations part, and that kind of adds up to deploying your models into production, but also monitoring your models. The big problem, and one of the things that I see a lot today, is people have this crazy idea that once they have trained their machine learning model, their job is done. Right? This is the typical approach for data scientists. It's like, hey, this model works, it's good. And then takes the model, throws it to the dev teams, go figure, use it. Right? Thing is, once you deploy a model, it might be that in 3 weeks or 3 months or 6 months, that model becomes useless because of a phenomenon that we call model drift. The data that model is supposed to be efficient in predicting on changes so much that the model becomes useless. So using models in operation also means monitoring and even detecting drift for those models. So when you try to mix machine learning and application development processes, today, in most cases, what you see is an approach that is scientifically called throw the model over the wall. Right? There's a big wall between app developers and data scientists. Data scientists are fiercely protecting their realm. Nobody should be allowed in there. Nobody should understand what they are doing because they are demigods, right? So once they have a model, a trained model, in most cases today, they throw it over the wall, and then app devs need to embed that model into the classical DevOps cycles. It's easy to understand why this approach, in most cases, if not all, is a good recipe for failure. This is not what you would like to see in your machine learning project. Actually, when you think a little bit about the processes that are involved in developing sound machine learning models, they look more or less like this. It's a cycle that starts from training models, packaging them, validating them, deploying them into production, and then monitoring them. And when once drift is detected, you need to redo the entire thing. And what you want to do actually is you want to have this as an end-to-end, fully automated process managed by a DevOps platform like Azure DevOps, for example. So this particular approach comes with a bunch of interesting challenges. And I've already touched on a few of them, like data and model versioning. You need to handle both of them. The other one is the traceability. You need to be able to produce a digital trail for any kind of audit that starts from a result produced by the model and ends with source code plus data that has been used to train that model. The patterns of reuse are different when it comes to machine learning model than the ones that are related to classical software reuse. And I will touch that in a moment. One interesting problem today that we face in the world of machine learning is that we realize that for some of the models, specifically for the very complex one, like the ones that recognize images and patterns and voice and things like that, only the largest companies in the world have enough resources to train them. So what happens is, what you will want to do is you will want to reuse machine learning models. And that is something that you will do typically, for example, through processes like transfer learning. This is also true if we kind of forget about the computing resources availability. It is also true when it comes to human resources. The number one problem with machine learning projects today is lack of human resources. There is a terrible shortage of people on this planet that really understand and are capable, understand data science, and are capable of producing sound machine learning models. So getting models from such folks, reusing them in your own processes is a unique challenge here. And also, as I mentioned, no model will ever live forever. You will always need to retrain those models, maybe every 3 weeks, maybe every 3 months, but you will need to retrain those models. So it's not a cycle that ends when a version is in production. It actually never ends. Hence, it's a cycle. The other thing is, when it comes to versioning and reproducing models, you need to be able to say at any given point in time, these were the basic building blocks: source code, process, data snapshot that have been used to train this model. And what we see a lot today is the data snapshot part is missing. And that is fine, things work, obviously, until that organization gets a serious audit. And when that serious audit comes in, then trouble begins, because you're actually not able to trace back your information. And that is even more difficult in Europe than in other parts of the world because of GDPR. One of the things is in GDPR is saying that a customer has the right to ask you how come they were classified, say, as gold customers. And you need to provide the answer to that. And unless you have end-to-end traceable processes, you won't be able to do that. The other thing is security and integrity. You need to be able to secure your models properly, not only in production, but also through the entire DevOps cycle. I've found countless situations where I was working in a project, and all of a sudden I popped on a blob storage or a file share, and I've seen a bunch of pickle files, right? Files with extensions PKL, and asking folks with that particular customer, what are these pickle files? Oh, they're just versions of classification models that turned out not to be good. Really? And you leave them here? Like totally unprotected, totally unsecured? Oh yeah, but they're just numbers. Really? I mean, a skilled data scientist can take a trained machine learning model and wreak havoc when it comes to understanding things that happen in your organization. So that is a problem. Same is model packaging. For example, Azure Machine Learning Service uses Docker containers. The approach that is the default approach for ML, for Azure Machine Learning Service, is takes your trained model, packages it into a Docker container, and then takes that Docker container and deploys it wherever a Docker container can run. And that is interesting because these days a Docker container can even run on the edge, like on a smart video camera or in a smart car or whatever. But it also can run in something like ACI, Azure Container Instances. Or it can run in AKS, in Azure Kubernetes Services, if you want super scalability. Or it can run on dedicated hardware that is built on FPGAs, on field programmable gate arrays, which will provide you immense performance in terms of the number of scorings that you can do with that dedicated hardware. And finally, obviously, and I've already mentioned that, I'm not going to talk too much about it, model deployment and monitoring. So this is a simplified architecture of an approach for DevOps in a machine learning project. We collectively refer this as MLOps, as machine learning operations. And as you can see, basically there are two core pipelines here. There is a build pipeline, and the core objective of the build pipeline is to basically instantiate an Azure machine learning training pipeline. Through that Azure machine learning training pipeline that you see on your right side of the screen, you are actually doing 4 major steps. You are training your machine learning model. Number 2, you are evaluating your machine learning model against the previous version of the machine learning model, because you don't want a machine learning model that is worse than the previous one to be published. If that check is passed, you will register your machine learning model with Azure Machine Learning Service, and finally, you will package the model. And that ends the training part of everything, the build pipeline part. And then once you have that, you can start your release pipeline, and that release pipeline will be able to deploy the results of the build pipeline either in a dev test scenario, which on Azure could be Azure Container Instances, ACI, or deploy it in a production grade environment, which in Azure can be AKS, Azure Kubernetes Service. And then as you can see, when you deploy into production, there is that connector that goes all the way around the slide to collecting telemetry data about the behavior of your model, for example, in a blob storage, and then at some point, a new retraining pipeline is triggered because, for example, model drift has been detected. So, let me now switch and start to show you some of the pieces of this. So what I have here prepared for today is I have an example of an end-to-end pipeline. I have stripped this out from a real project that we have. This is a machine learning model that predicts for descriptions of car parts, whether they are compliant or not. So we have basically a model that does some natural language processing and then does some classification on free text descriptions of car parts, and will say, yes, this is compliant, yes, this is not compliant. And at the end of the day, the model gets pushed into production in the form of a service that exposes a REST API, and that service does predictions for new descriptions of car parts. So what I have here is the repo, the source code of the project. And what is important here is we have even the definitions of the Azure DevOps pipelines handled as source code. As you probably know, for quite some time now, Azure DevOps supports defining your pipelines in YAML files. So even the structure of the pipelines for Azure DevOps is handled in YAML files, is handled in source code. So here's the example that I'm having here. And this is a simple release pipeline. I'm going to walk you through it very quickly. I don't want to get into all the details. But basically what we are defining here at the very, very beginning is connection to, I think I should increase this a little bit. Is that better in the back? Yeah, okay. So this is information to connect Azure DevOps to Azure Machine Learning Service, because if you think about it, these are two completely different services, and they need to work together in a shared security context. So what we're providing here as variables for the pipeline are the name of the resource group, the name of the Azure Machine Learning Service workspace, and by the way, this is the Azure Machine Learning workspace that we are having here. This is an Azure Machine Learning workspace, and it has a compute resource. I hope my internet connection is going to work. Yep. So we have a compute resource that is called MLCompute 01. And this compute resource currently has a maximum number of 1 nodes. And let me update it so it will start this particular node. So we are providing this connection. Now, the first question here is, yeah, but how do they authenticate between Azure DevOps and Azure Machine Learning Service? And there is a setting here. Sorry, at the tenant level in organization settings. Bear with me a moment, please. My screen is very large and I Yoo-hoo. This is really, really weird. Because I should see it and I don't see it. Yes? Oh yeah, cool. This is when you're used to work on a 4K monitor. So, basically what you do here is you define a service connection, and the type of service connection that we have defined here is an ARM service connection, and this service connection, I will need to make that smaller. This service connection will enable you to connect a subscription and let me find my own subscription. Yes. And then you can provide a resource group, and then you can provide the name of the Azure Machine Learning Service. So through such a service connection, like the one that we already have here defined, and as you can see, this is an ARM, it's connected to the service using service principal. This is basically the core way through which we are configuring the security between the two of them. Let me move on now. The first task that this particular pipeline does is installing the requirements. Please note that the VM image that we are using is on Ubuntu, so it's a Linux box. This runs on Linux boxes. So the first thing is we're installing requirements, and the requirements are specified as well in our repo in the install requirements shell file. And as you can see, we have, this is being a simple pipeline. We have only one requirement. We need the Azure ML SDK being installed as a requirement. The next step the pipeline does is it installs the Azure CLI. Through the Azure CLI, we are communicating with the Azure Machine Learning Service and with the basically with the entire Azure portal. Next thing is we are attaching to the workspace, and this is where we are using that service connection. Next step, this is where things become interesting. So the next step, we are either creating or getting a handle to the Azure Machine Learning Compute target. And as you can see, what we're doing here, basically, we are running a script named createMLCluster.py. And let's take a look at that script. So the createMLCluster.py, what it does is basically creating an ML compute provisioning configuration. And as you can see, we are using a standard D2V2 configuration with a minimum of one node, a maximum of one node, obviously for demo purposes, and then we create it. And here's an interesting thing. For the purpose of the demo, I have already created the compute resource. But using this approach, think about the following. You don't need to have the compute resource. You only need to create that compute resource when the pipeline runs. So as part of prepping the pipeline, what we are doing here, we are making sure that also the infrastructure needed for the training process is dynamically created. So we are basically creating an Azure Machine Learning Compute cluster here in order to train our models on it. And obviously, when all things are done, that cluster can be tiered down. Or if you define the minimum number of nodes being 0, like you've seen when I changed the properties of my cluster, then that cluster, after a certain amount of time when it's unused, will automatically delete all the nodes and get back to 0 nodes until it is needed again. So let's get back to our pipeline. Once we have the compute target, we are actually creating the Azure machine learning pipeline that will actually train our models. And as you can see here, we are running this Python file, pipelinesmaster.py. And let's take a brief look through what Pipeline Master does. It gets a handle for the workspace, for the Azure machine learning workspace. And as you can see here, I've riddled all of this with messages just to help logs be more readable and easier to follow through the process. This is not something you will normally do in such code. And then you are basically defining a run configuration. A run configuration is basically a set of data, a set of information that defines the type of environment that Azure Machine Learning Service must prepare for your workload. And as you can see, it is Docker enabled. It will use a default CPU image. So it's not a GPU enabled one, it's a CPU enabled one. And then it will at some point specify a set of dependencies. And here are some of the dependencies that we need to use. And as you will in a moment see, we are relying here on Keras and TensorFlow to create a deep learning machine learning model. So these are the dependencies that we need to have in our environment. And it will obviously set up all these dependencies in the environment. And finally, we are creating a pipeline, an Azure machine learning pipeline with two steps. The first pipeline step is handled by the train.py script. And I will get back to that in a moment. This is the script that creates the actual part where the training of the machine learning model takes part. And one important thing here, please note, is we are injecting here the build number that comes from Azure DevOps. And what happens when we train the model and then we register the trained model with Azure Machine Learning Service, we will tag the model, the trained model, the version of the tagged model, of the trained model, we will tag it with the Azure DevOps build number. Which means that at any given point in time, when you look at a machine learning model used by Azure Machine Learning Service, you will be able to find the build number. And by the build number, obviously you will be able to go back and trace the exact version of the source code that has been used to train that particular machine learning model. This is very important for backwards traceability. And then the second step of the pipeline is the step that runs evaluate.py. And evaluate.py basically evaluates the performance of the newly trained model and compares it with the performance of the previous model that has been published. Just to make sure that you don't publish a model that has worse performance than the one that you already have. Since this obviously is a full CI/CD DevOps environment, meaning that every single time somebody does a PR, we only have one branch here, the master, but suppose you have a normal approach where you have like a dev and a release and so forth. Every time somebody does a PR into the release branch, the pipeline automatically executes. So you need to make sure that you're not publishing things that are not meant to be published. And then the final part of this is finalizing the pipeline and basically running the pipeline as part of an Azure Machine Learning experiment. The experiment is the object that basically contains all the information in Azure Machine Learning Service to run your training workloads. So let's take a look now to the two scripts that I have mentioned, train and evaluate. So without getting into the nitty-gritty details of what happens here, we are getting our data, and this is not part of my demo, but this data has already been snapshotted into an Azure Blob Storage. One of the things that I impose to the teams that I work with in machine learning projects is never, ever implement an MLOps pipeline with live data. You should never have something like select star from customer transactions, where customer transactions not older than 2 years, right? You're not allowed to do something like that. Every single time you need to first snapshot your data, no matter how big it is. Today, honestly, storing data is not an issue anymore. So even if your training data set is 1 gigabyte or 1 terabyte or 10 terabytes, I don't care. You need to snapshot the data, which means that that particular snapshot should be available from now until the end of the time or until we decide that it's not necessary anymore to replay this process as many times as needed. Even if that will never happen, the data still needs to be there because at some point in the future that needs to happen. And then we are downloading here the glove embeddings. This is a special file that enables us to transform natural language into numerical vectors. I'm not going to get into too much detail with that. We are splitting the text into tokens, and then we are embedding those tokens as vectors. And finally, here, we are creating a TensorFlow model, machine learning model, using Keras. This is basically an encoder model that takes that. So the flow is like this. We take initial free text description, we tokenize it into words, we transform every single word into a vector of 100 numerical values using the glove embeddings. This is a standard approach in natural language processing. And then we feed that representation into this particular deep learning model, which, as you can see, has exactly one output, compliant or non-compliant. And our test data set has a few tens of thousands of descriptions of car parts who are either compliant or not compliant. And then once we train this model, when we get a new free text description, this model will be able to predict whether that particular car component is compliant or not. And finally, we are basically training and then registering that particular model. Here's the training part, where we do model.fit, and here's the registering part, where we register the model with Azure Machine Learning Services. And then evaluate.py is the part of our pipeline that gets the model. So we take the latest model that we have published, and then we check the accuracy of that model. And without getting into more details, eventually we will check if that particular accuracy is better or not, and if it is, we go on with the model. So let me go now to pipelines. And as you can see here, I have started this pipeline a few minutes ago, right before our session, to make sure it will finish. So this is a fresh pipeline, a brand new one. And let's take a look at its history of running. So as you can see here, we've had every single, every single step here, we've had it run, installing the CLI, installing the requirements, and as you can see, it has collected a huge number of Python packages. Basically what happens here, think about this. You get a brand new Linux box with nothing on it. You install the Python environment, you install all the packages on it, you install your dependencies, and then you create on the fly an environment that is ready to run your own Python code, which is the code needed to communicate with Azure Machine Learning Service and start that training. And then we have the get or create the compute target, and as you can see, at some point here, There's a lot of stuff happening, so this is really, really complicated stuff that happens behind the scenes. Azure DevOps simplifies it a lot. And here you can see we have found an existing compute target. So the compute target was already there. We found it. We're going to use this. And then finally, we have the master pipelines. And this is really, really long. I'm not going to get into the nitty-gritty details of it. By the way, this is the part where we have trained the deep learning machine learning model. As you can see, we've had one epoch with 90,000 entities and then the detailed log of everything that happened. And by the way, the reason why I'm showing you this is because I want to show you that every single thing that happened in this super complex process of preparing infrastructure, getting the data, training the model, comparing the model, every single thing is recorded. So basically, if anybody asks me, hey, Ciprian, what was the loss when you trained the deep learning encoder at step 56,480? And I would say, yeah, the loss was 8.0242. I do have this information, right? It sounds crazy, but this is what we should have in machine learning projects. So finally, because we are close to the end of our time, let's now go to releases. And let's see for our run here. What happened with the release? So as you can see here, with the logs, I have a different pipeline, which is my release pipeline. I have installed requirements here because the release pipeline was automatically triggered by the build pipeline. And then finally, I did deploy and test the web service. And by the way, when I say deploy and test the web service, I actually mean testing that particular endpoint. So if I go back to my environment, okay, and I go to experiments, actually this is not the environment that I'm looking for. Sorry about that. Too many Azure machine learning environments, right? So it should be somewhere here. Yep, launch the studio. There's a new UI for Azure Machine Learning Service that has been released. So let me switch directories. Yeah, thank you. You gotta love that, right? Every single time. I mean, last thing I want to show, and it asks me, sign in, dude. Okay. So let's go with the machine learning workspace. And let's go with the experiments. And as you can see, the latest run, my experiment was quick starts MLOps. And it has completed. I have in my pipelines here the details of running the pipelines, the train and the evaluate pipeline. So everything that happened that was shown in DevOps. And then I have the models, and I have the compliance classifier model, which was created here. It's the 6th version. I've done this demo several times, so I now have this compliance classifier model here. And I have the compliance classifier endpoint here, which is actually an AKS endpoint, an Azure Kubernetes Service endpoint, where I can directly call my trained model using Azure DevOps. And hopefully this will load at some point in time, because we're 1 minute over time. Bear with me 10 seconds, please. Hello. Okay. In the same time, if we take a look here at inference clusters. Okay, perfect. So here's my endpoint. I would like to show the details about that endpoint, but for some reason that is not. You will have to believe me that that is an actual web service endpoint. So I was able to show you everything, but not the details of the URL of the endpoint. There's probably something wrong with my internet connection. So having said that, what I tried to show you from 10,000 feet today is a comprehensive approach for handling machine learning projects with DevOps principles. And that started from handling everything in source code, including the definition of DevOps pipelines, addressing all the things related to traceability, to versioning, through Azure DevOps combined with Azure Machine Learning Service, and basically taking an end-to-end approach where the final result is a deployed web service endpoint resulted from training that particular model. With that, I thank you very much, and I wish you a great remainder of this day. Thank you.